Ever get that feeling where a topic just completely hooks you? You just can't stop thinking about it. I think for a lot of us, the idea of time travel is kind of like that. Movies, books, just laying in bed at night thinking, what if? The whole concept of hopping through time, forward or backward, it's just endlessly fascinating.
Oh yeah, definitely. And for this deep dive, we're going beyond just fantasy. We've got this really interesting collection of different perspectives on time travel. Videos, text, all sorts of stuff. We're talking everything from ancient myths to some really advanced physics. Our main goal today is to really understand what these sources are saying about the possibility of time travel. Could we really journey into the future? And maybe, just maybe, revisit the past.
So we're really going to dig deep into this. Is building a time machine actually possible? Or are there, rules of the universe, maybe even mechanisms we don't fully understand yet that govern time? We're talking Einstein theories, ancient stories about time travel, and even a bit of quantum mechanics. So if you're the kind of person who loves those aha moments and you want to learn from a bunch of different angles, this deep dive is for you.
Right. And a good place to start is with the idea of traveling to the future. Most of the sources we looked at seem to agree that, at least in theory, it's the more straightforward direction.
I agree. And to illustrate this, the videos use the example of astronauts on the International Space Station. I mean, they're orbiting the Earth at insane speeds, and that actually affects how they experience time. It's incredible.
It really is. The infographic show video uses the story of Scott and Mark Kelly, those twin astronauts. Scott spent way more time in orbit than Mark, and because of that, he actually aged a little bit less. We're talking like fractions of a second here, but still,
No.
It's a real-world example of time travel, just on a tiny scale.
So even at speeds that are, relatively slow compared to, say, the speed of light, time isn't as constant as we might think, right?
Exactly. Time is flexible. That's what Einstein's theory of special relativity tells us. The faster you move, the slower time passes for you, compared to someone who's standing still.
So that's like that hypothetical scenario in the History of the Universe video, the
Yeah.
one where if you could travel at 99.999% of the speed of light, a single day for you would be like almost 200 years on Earth. It's wild.
It is mind-blowing, isn't it? And
Yeah.
it all comes down to time dilation, a core concept in special relativity. That's what that pasted text source emphasizes. Time dilation opens up a path to the future.
So theoretically, if we could build a spacecraft that could reach those insane speeds, we could actually fast forward into the future.
That's the idea. Of course, building a spacecraft like that comes with huge technological challenges. But hey, maybe someday.
Now, it's not just speed that affects time, right? Gravity plays a role too, according to Einstein's general relativity.
You got it. General relativity tells us that time slows down in stronger gravitational fields. You know those experiments they talk about in the History of the Universe video? The ones with atomic clocks placed at different altitudes? Well, the clock that's closer to the Earth, where gravity is stronger, ticks a tiny bit slower than the clock that's higher up.
So just being on Earth with its gravitational pull means time is moving slightly slower for us than it would if we were, say, floating out in deep space.
Exactly. And this isn't just a theoretical curiosity. It actually has practical implications for things we use every day, like GPS. You see, GPS satellites are farther from Earth's gravity. And they're also moving pretty fast, so scientists have to adjust their clocks constantly to make sure they give us accurate positions.
It's incredible to think that something as basic as getting directions on our phones depends on the fact that time is an absolute.
It really is.
Yeah.
And you know that bus trip they talk about in the video, the one Rossi took up Mount Evans? It also demonstrates this in a more down-to-earth way.
Oh yeah, what was that all about? I remember it had something to do with muons.
Right. It's all about those muons. Those are subatomic particles that decay really, really quickly. Rossi basically found that more muons reach the ground from higher up than scientists expected. And the reason? Time dilation. Because they're moving so fast, time slowed down for those muons, and more of them survived the trip.
So that's another real-world confirmation of Einstein's theories. So from all these examples, it seems pretty clear. Traveling to the future, at least in theory, is possible. It's all about time dilation, which is caused by extreme speeds and strong gravity. The big challenge, of course, is the technology. Actually building a spacecraft that can travel near the speed of light or figuring out how to manipulate gravity, that's a whole other story.
Absolutely. And it's funny how the infographic show sums it up. To travel to the future, all you have to do is move incredibly fast. Simple.
If only it were that easy in practice. But now let's get to the really tricky part, traveling to the past. This is where things get really complex and really, really interesting.
That's where we start running into all sorts of paradoxes and challenges. It really makes you think. And one interesting thing is that the idea of traveling to the past isn't new. It actually pops up in ancient myths and legends.
Oh, that's right. The History Channel video talks about that. Some researchers think those ancient stories might actually be early accounts of time travel, or at least a sign that people have been thinking about this idea for a very long time.
Exactly. They point to stories like the one in the Mahabharata about King Ravita. He travels to Brahma's heaven and comes back to Earth hundreds of years later. It's kind of like what happens with space travel, where a short trip for the astronaut can be years on Earth.
That's a really interesting parallel. And there's the Japanese legend of Urashima Taro, right? The fisherman who spends what he thinks is 3 days in an underwater palace, only to return home and find that 300 years have passed.
That's a classic one. And it really captures the potential consequences of time travel. Imagine coming back to a world where everything and everyone you knew is gone. It doesn't bear thinking about.
And then you've got the story from the Hebrew Bible, the one with Abimelech. He goes to get some figs and somehow ends up 62 years in the future.
Yeah, that story has a very similar structure to the other legends. It's like, boom, sudden time jump.
It really does make you wonder. Whether these stories were meant to be literal or metaphorical, they definitely show that the idea of manipulating time has fascinated people for centuries. And now, modern science is starting to explore those possibilities more seriously.
Right. And it turns out that even Einstein's theories, which were revolutionary, didn't completely rule out backward time travel. The History of the Universe video mentions a paper by Willem Jacob van Stockum. Back in 1937, he showed that Einstein's equations, specifically the ones for general relativity, actually allowed for something called closed time-like curves.
Closed time-like curves, that sounds complicated. It's like time loops, right?
That's a good way to think about it. It's basically like a path through space-time that loops back on itself, potentially allowing you to travel back to a point in the past.
So even Einstein, unintentionally, opened the door to backward time travel, at least mathematically. But the big question is, how do you actually create one of these closed time-like curves? The sources talk about some theoretical possibilities, starting with, well, wormholes.
Wormholes are definitely one of the most popular ideas.
Mm.
The infographic show describes them as tunnels that could connect different points in space-time, and maybe even different points in time. The idea is that you could manipulate the mouths of the wormhole to create a time difference between them. Like if you moved one mouth really fast relative to the other.
You could step into one end in the present and pop out the other end in the past.
In theory, yes. But there's some major caveats here. First, we haven't actually found any wormholes. And second, even if we did, keeping a wormhole open and stable enough for a person to travel through would likely require something called exotic matter.
Exotic matter? What's that? Some kind of super rare element.
It's not really an element. It's more like a type of matter that has negative energy density. It's theoretical, and we don't even know if it actually exists. The pasted text source goes into more detail about this.
Okay, so wormholes are still very much in the realm of science fiction. They sound cool, but with all the challenges, it doesn't seem like they're going to be our ticket to the past anytime soon. What about some of those other mind-bending ideas, like the Tipler cylinder?
Oh, the Tipler cylinder. That's another fun one. Both the infographics show and the History of the Universe videos talk about that. It's basically this hypothetical cylinder, super massive, super long, ideally infinitely long, and it has to spin incredibly fast.
An infinitely long spinning cylinder. Okay, that sounds pretty impossible.
You're not wrong.
Yeah.
The idea is that if you could create a cylinder like this, the spinning would warp space-time in a way that would allow backward time travel if you followed a very specific path around it. But even Stephen Hawking, as the History of the Universe video mentions, thought it would require a ton of that exotic matter to work.
So it seems like no matter what we try, we keep hitting the same wall. We need this exotic matter that might not even exist. It's almost like the universe is trying to prevent us from messing with time.
Maybe so. And then there's the concept proposed by Amos Ori. They talk about that in the infographics show. Ori's idea involves using gravitational waves to create a donut-shaped vacuum in space, which could, in theory, allow for travel to the past.
A donut-shaped time machine. I like the sound of that. But I bet it's not that simple.
You're right, it's not. The big problem is that we can't really control gravitational fields precisely enough to do something like that. Not yet, anyway.
So even with all these crazy ideas, the reality is that traveling to the past is incredibly difficult, maybe even impossible. But even if we could overcome all the technical challenges, there's still the problem of paradoxes.
Ah, yes, the paradoxes. the logical nightmares that come with the territory. And probably the most famous one is the grandfather paradox. The infographic show explains this really well. What if you go back in time and accidentally prevent your grandfather from meeting your grandmother? That means you'd never be born, so you couldn't have traveled back in time in the first place.
It just ties your brain in knots, doesn't it? It's a classic example of how messing with the past can lead to logical contradictions.
Absolutely. And our sources explore some of the ways physicists have tried to deal with these paradoxes, like Stephen Hawking's chronology protection conjecture. He basically suggested that maybe there's a law of physics that prevents us from traveling to the past to avoid these paradoxes.
So maybe the universe has a built-in safeguard to keep everything consistent. Then the history of the universe video brings up another idea, Igor Novikov's self-consistency principle. What's that all about?
Novikov's principle says that you can travel to the past, but you can't change it. So let's say you went back in time and tried to, I don't know, stop your younger self from doing something. Novikov's principle says that something would always happen to prevent you from changing the past. Maybe you trip and fall. Maybe your plan backfires. Something like that.
So the past is kind of like a movie you can rewatch, but you can't change the ending.
Exactly. But then the history of the universe video throws a wrench in the works with the example of those colliding colored balls.
Oh yeah, what was that all about? It involved a time machine, right?
It does, and it's a real head-scratcher. Basically, it sets up a scenario where, to keep the timeline consistent, a ball would have to be two different colors at the same time. It's meant to challenge Novikov's principle and show that maybe things aren't so simple.
So even with all these theories, the paradoxes of time travel to the past are still really tough to reconcile. But then we have quantum mechanics. Could that be the key to solving these puzzles?
That's what the History of the Universe video and the infographic show suggest. Specifically, they talk about the many worlds interpretation of quantum mechanics. It's a wild idea.
The many worlds interpretation, isn't that the one where every decision, every tiny quantum event splits the universe into multiple realities?
That's the one. It's
Yep.
like every time there's a possibility of something happening, the universe splits and all those possibilities play out in separate timelines. The History of the Universe video uses the example of quantum Russian roulette. Imagine that.
Okay, so how does this idea of parallel universes help with the paradoxes of time travel?
Well, if you travel to the past, you might not be traveling to your own past. You might be ending up in a different timeline, a parallel universe. So let's go back to the grandfather paradox. If you travel to a parallel universe and prevent your grandfather from meeting your grandmother, you're not erasing yourself from existence. You're just changing the course of that particular timeline.
So you're essentially creating a new reality where a version of you doesn't exist, but your original timeline is safe. It's mind-blowing, but it does seem to get around those paradoxes.
It does. And the History of the Universe video uses this to explain the bootstrap paradox as well. You know, the one where something seems to exist without an origin, like that letter they talk about.
Right. The idea is that the letter comes from a different timeline, so it doesn't actually need a starting point in your reality.
Exactly. It's a very elegant solution. But the many worlds interpretation, as fascinating as it is, isn't without its own issues. It means there would be countless parallel universes out there. It's a lot to wrap your head around.
Okay, so we've covered a lot of ground here. We've talked about time dilation, wormholes, paradoxes, and even parallel universes. What are the main takeaways from all this? What did we learn about time travel?
Well, when it comes to traveling to the future, the sources seem to agree that it's possible, at least theoretically. Time dilation, which is caused by speed and gravity, is a real thing, and it's based on solid physics. The challenge is the technology.
So future travel is more of a when question, not an if question. But traveling to the past is a whole different story.
Exactly. The sources really emphasize how tricky backward time travel is. There's so many challenges, from the theoretical concepts like wormholes, which require exotic matter, to the paradoxes that seem to break logic. And then there's the question of whether the universe even allows backward time travel. Maybe there are fundamental laws of physics that prevent it, as Hawking suggested.
And then you have quantum mechanics, which offers these really mind-bending possibilities with the many worlds interpretation and the idea of parallel universes.
Right, the many worlds interpretation could provide a way to resolve those paradoxes. But it also raises all sorts of other questions about the nature of reality.
So it seems like traveling to the future is a question of technology, but traveling to the past is more of a fundamental question about the universe itself. It's about physics, logic, maybe even philosophy.
That's a great way to put it. And it leaves us with this really interesting question for you to think about. If You could travel to the past. Which timeline would you end up in? Would you even be able to change anything in your own reality, or would your actions just ripple out into a parallel universe? It really makes you think about the nature of time and free will.